Hi, this is Adam Griffin again with the second video for the first week of Video Explainers. This one is in a little bit of a different style than the last one, but hopefully it works okay. And I also apologize for any echo. The apartment that I'm living in is very empty. So this problem that we will be solving in this video is number 55, and we have a rocket with 100 kilograms of fuel accelerating straight up at a constant rate of 30 meters per second squared for 30 seconds before it runs out of fuel. So we can take this acceleration and get the derivative of it, which will give us velocity, and that is equivalent to equals our initial velocity plus our acceleration times the amount of time that has passed. So our velocity equals 0 plus 30 times 30, which gives us a velocity of 900 meters per second when the fuel runs out. So when the fuel runs out, we can also figure out the position that the rocket is at with the equation for position. So this is our position, and it is equal to the initial position plus the initial velocity times delta t, so the change in time, plus 1/2 of the acceleration times our change in time squared, which is equal to our position being, that is 0 times, and our initial velocity is 0, so that equals 0 plus 1/2 times 30 squared, which gives us, this part is 900 and this is 15, which comes out to 13,500 meters. So that is our answer for position when the rocket runs out of fuel. So now we can figure out our maximum altitude by plugging this in for our initial position and 900 meters per second for our initial velocity, which is what we calculated last time. And that will give us 13,500 plus 900 times our change in time, which we do not know yet, times, or plus 1/2 times negative 9.8, because that is gravity, and it will subtract 9.8 meters per second squared every second, times, and then our seconds squared. I apologize for the dog in the background. So we can work this out and we can plot this, and when we do plot it, the graph will look something like that, very tall. Up here we find that the max height is at about 91, and our absolute maximum height is 54,826 meters. And that's our answer for A. And then for B, we find this point and we figure out how many seconds, which is represented by x. So our time, when we plot this out, intercepts the x-axis at 197.615. So our rocket hits the ground 197.6 seconds after